I did ask Adler if anybody needed to see number 4, and you were talking back there, so I didn't think you were correcting it. I still have the key if you need to see it. Don't say I just didn't show it. Okay, for today we are going back, so we already wrote equations of parabolas, or rather we rewrote equations that were in a general form and wrote them into standard form. Then yesterday we still worked with rewriting them into standard form so we could graph them. Today you are given characteristics of a parabola and you are asked to write the equation of that parabola in standard form. So this is where you need your formulas. And I'm going to model with number 1 how to kind of think through this and problem solve through these. So example 1 gives you that the vertex of the parabola is -2, -4, and the directrix is y equals 1. So what I usually do first, this isn't something you have to do, but I find it easiest to know which way this parabola is opening so you know which formulas you're looking at on your graphic organizer. So I usually make a sketch of the information that I have. So I'm just going to sketch a coordinate plane and actually plot the vertex and draw in the directrix so I can figure out which way this parabola is opening. So I know the vertex is -2, -4. So just plotting where that vertex would be approximately. And if the directrix is y equals 1, is y equals 1 a horizontal or a vertical line? Horizontal. So it's going to go through the y value 1, but it is a horizontal line. So look at your graphic organizer. Which way would this parabola be opening if the directrix is horizontal and it's above the vertex? It's going to be opening down. Okay, that's helpful to know for a few reasons. One reason, I know then if the parabola is opening down that my standard form is y equals, not x equals. So my standard form is going to be y equals a times the quantity x minus h squared plus k. And what I need to identify is I need to know the a value, the h value, and the k value in order to actually write my equation. Those are the 3 things I need to use the information I have to find. And then I can use the formulas I have based on what I'm given to find a, h, and k. So any ideas on what any of these 3 values would be based on what we're given? H is -2. H is the x value of the vertex. Adler? So when we put the value into the equation, this will be x plus 2 then, because it'll be x minus -2. But the x value of your vertex is h, so h is -2. Any other values we know? K is -4. So the vertex is always hk. It's nice when you're given the vertex because you're given two of the 3 values that you need. The question then is, how do we find a? So if you look at your directrix, and I'm actually going to write down from my graphic organizer, for a parabola that opens down, this is the formula I have for the directrix. I know that the directrix has the formula y equals k minus 1 over 4 times a. And I can use that because I know the directrix is y equals 1. So that must mean that 1 is equal to k minus 1 over 4a. Okay, so I can set up an equation there. If I know the directrix is y equals 1, I know 1 then is equal to k minus 1 over 4a. I know what k is. I've already identified k is -4. I can substitute that in. So I have 1 equals negative 4 minus 1 over 4a. And now I have an equation that I can solve for a. What would you do first in this equation to solve for a? Add 4. So 5 equals negative 1 over 4a. What would I do from here to solve for a? Yes, but I would add in there, I don't want, because if I just multiply by negative 4a is still going to be in the denominator. So I'm actually going to multiply by negative 4a to get the a out of the denominator. Okay, so then the negative is canceled out on this side, and the 4a's are canceled out. So on the left, I have negative 4a times 5. I can multiply the 5 and negative 4, so I have negative 20a is equal to, then I just have 1 on the right side. But now I can divide by negative 20, and I get a is negative 1/20. I would leave a as a fraction. It really, if the fraction ends up being a terminating decimal, it's fine if you write a decimal. But otherwise, I would leave a as a fraction. And make sure you simplify it if you need to. So I have my a value then is negative 1/20. And once you have a, h, and k, you just substitute them into your standard form to get your equation for your parabola. So this parabola has the equation y equals negative 1/20 times the quantity. Now again, since h is negative 2, if I have x minus negative 2, that'll be x plus 2, quantity squared. And then I have plus k is negative 4. So I could write plus negative 4 or just put minus 4. And that is the equation of the parabola. Are there questions on example 1? Okay, so number 2 gives you the vertex and the focus, but I would like you to try number 2. So I would recommend sketch these 2 points to figure out which way the parabola opens, and then use the vertex and the focus to find a, h, and k. I just want to give you a chance to work through it, and then we'll make sure we can all get it and make sure we have the right answer. And juniors, I know you're going to be called out, could be during this example, but I'll make sure you see the correct answer before you leave too. Just like your vertex is HK. Your focus, your K is not 5. K plus 1 over 4A, this whole thing is 5.
Attention all juniors. Juniors, please grab your device, a pencil, and your note card with your name if you have it. If you don't, we have extras. And please go to the auditorium right now. Again, all juniors, please go to the auditorium with your device and a pencil. Thank you. Very similar to how we did this one. Okay, I know some of you might still be finishing up, some of you have it. I just want to kind of show this and then let me know if you have questions. So I very strongly recommend that you plot on a grid. Now here's 2 points, so you plot both points, determine which way it opens. That really gives you an idea of what formulas you're using. And I think most of you had identified when I had walked around to check, so H, K, H is 1, K is 3. And then you would use an equation for the y value of the focus. So since the y value of the focus is K plus 1 over 4A, and you know that it's 5, you can set up this equation, 5 equals K plus 1 over 4A, and solve for A to get 1/8, or if you had a decimal, 0.125. I would try to leave a as a fraction because if you have a repeating decimal, you need to leave it as a fraction anyway. Are there questions on number 2? Okay, then we're going to move on to example 3. Example 3 starts out with the same idea, just works out a little bit differently. So in number 3, you are not given the vertex. So it's very nice when you are given the vertex because then you have 2 of the 3 values you need. This one gives you the focus and the directrix. So I would still plot the focus and then draw in the directrix on a graph. So the focus is at 5, 6. And sometimes, I didn't point this out in the last one just so you don't get things confused. Like in the last one, because I was plotting 2 points, I put a V by the vertex and F by the focus, just so when I'm looking at it, I don't switch the 2 around. So here I'm just making a note, this is the focus, not the vertex. And then I have the directrix, which is x equals -2. So is that a horizontal or a vertical line? Vertical, yes. If it's x equals, it's vertical. So I need to go through the x value -2. But it is a dashed vertical line then for the directrix. So if you look at your graphic organizer, which way would this parabola open if the directrix is vertical and is on the left side of the focus? Right. Okay, you don't have to sketch the parabola in, but it's just so you know which way it opens, so that way you know which box you're looking at on your graphic organizer. So this one has the standard form x equals a times the quantity y minus k squared plus h. Okay, we still need to find a, h, and k. Looking at your formulas for the focus and the directrix, are there any of those 3 values that we know? Which one? K? What is K?
6.
K is 6. Okay, so in your focus, if the parabola opens to the right, the y value of the focus is the k value. But then for the x value of the focus and then also for the directrix, we have formulas for both of those. So we don't know h or a. The x value of the focus is h plus 1 over 4a, and the directrix is x equals h minus 1 over 4a. So what I have to do here is actually set up 2 equations. So I would have h plus 1 over 4a is equal to 5, the x value of the vertex. And then for my directrix, I have h minus 1 over 4a equals -2. I wrote the two equations, one underneath the other one on purpose, because what you have here then is a system of equations with two variables that you need to solve for. Remember, systems of equations you can solve with substitution or elimination. So if you look at this system, notice in one equation you have plus 1 over 4a, the other you have minus 1 over 4a. That means if I add these two equations together, the 1 over 4a's eliminate. And that allows me to solve for h. So I have h plus h, so that would be 2h. And then 5 plus negative 2 is 3. Solve for h, divide by 2. So h is 3/2, or if you wanted to write h as a decimal, you could write 1.5. I'll leave it as a fraction. I'll leave it as 3 over 2. So we have h. And then now that we have h, how could we find a? How would we find a? Yes, using one of these. I would probably use the one that was plus 1 over 4a. That's just my preference. So I'm going to substitute this back in up here. So I have, and substituting it back in, working with the decimal might be a little bit easier, but it doesn't really matter. So I have, let's see here, 1.5 plus 1 over 4a equals 5. And then I would solve this for a like we were doing in the previous two examples. So I would subtract 1.5 from each side. 1 over 4a is equal to 5 minus 1.5 is 3.5. And then I would multiply each side by 4a to get a out of the denominator. So 1 is equal to 3.5 times 4 is 14. So 14a. Divide by 14. And a then is 1/14. Okay, and then once you have a, h, and k, substitute them in. Make sure you're putting h and k in the correct place. So we have x equals 1/14 times the quantity y minus k, which is 6. So y minus 6 quantity squared, plus h, which is 3 over 2, or 1.5 if you had it as a decimal. That's the equation of the parabola described. Okay, any questions on 3? For parabolas, they probably involve the most work if you're not given the vertex. So you've kind of seen the different combinations of characteristics you might be given. Number 4, though, so this is still the same idea. Number 4 is giving us some information. We need to then apply it, make a sketch, figure out how to find a, h, and k to write our equation. Number 4 says solar energy may be harnessed by using parabolic mirrors. The mirrors reflect the rays from the sun to the focus of the parabola. The focus of each parabolic mirror at the facility, it says described at the left. I don't have that description, so I'm sorry. Is 6 points, so I probably could have taken this out. So the focus of each parabolic mirror is 6.25 feet above the vertex. The lattice rectum is 25 feet long. assume that the focus is at the origin, write an equation for the parabola formed by each mirror. Okay, so I'm going to go back. I am first going to do what we did in the first three examples, make a sketch. So let's see, I'm given that the focus is 6.25 feet above the vertex. I'm given the length of the lattice rectum, and I'm told that the focus is at the origin. So the focus is at the point 0, 0. So if I were to make a sketch of this, 0, 0, this is my focus, which I'm told is 6.25 feet above the vertex. So the vertex would be 6.25 feet below the focus, meaning the focus is at 0, 0. What would the coordinates of the vertex be then? Close. 0 would be the x-coordinate, negative 6.25 would be the y. Yes. So I have this parabola. I can tell based on the placement of the focus and the vertex, it's opening up. And then I'm also given the length of the lattice rectum. So if I were to draw that in, remember that's the line segment that goes through the focus and has endpoints on the parabola. But I know that lattice rectum is 25 feet long. Okay, and I'm writing an equation for this parabola. So first of all, I know that it opens up. So I know the standard form is y equals a times the quantity x minus h squared plus k. I need to find a, h, and k. We were not given the vertex, but we were able to find it with the information we had. So we know since it's hk, we know h is 0 and k is negative 6.25. We just need to find a. Now, there are multiple ways we could find a here because we do have the focus. And in example 2, when we had the vertex and the focus, we were able to find a using the focus. However, if you're given the lattice rectum, finding a is a little bit easier using that because you know the length of the lattice rectum is the absolute value of 1 over a. And we know that it's 25. We know that length is 25. So we can set up an equation given the length of the lattice rectum formula that we have. Now, for the absolute value part of this, how you have to assume this is because the parabola opens up, is the a value going to be positive or negative? Positive. So I'm just going to make a note here, a is greater than 0. So that's how I can get rid of the absolute value bars, and I can say 1 over a then must equal positive 25 because the a value is positive because it opens up. So if this parabola was opening down, I would then have 1 over a equals negative 25. So you have to interpret with the absolute value if your a should be positive or negative based on which way it's opening. And then here, to solve for a, I can multiply both sides by a. So I have 1 equals 25a, and then divide by 25. So I would get a is 1/25. And like I said, I know it's positive. So the equation of this parabolic mirror would be y equals 1/25 times the quantity. Now here, I'm going to show you two ways you could write this. I would accept either one. Since h is 0, I could write it as x minus 0 quantity squared and then minus 6.25, or
You don't need to have x minus 0. X minus 0 is just x, so you could just have 1/25 x squared minus 6.25. If you included the 0 and had x minus 0 squared, I would not mark that wrong. So you could have either one. Any questions there?